Let's take a look at two properties for rational exponents. So remember, the word rational just means that you have a number that is a ratio, which is just another word for a fraction. So if we are going to look at rational exponents, it means that the number in the spot of the exponent is now going to be a fraction. Okay, let's take a look at our first property. We have x to the power of 1 over n becomes the nth root of x. So notice how the denominator of the exponent becomes the index on the radical, and then the base of x becomes the radicand, which is the number that goes under the radical sign. So x to the power of 1 over n is the same as the nth root of x. Okay, let's look at the first example. If I have 8 to the 1/3 power, that means I have a radical sign, but the root is 3. So this isn't square root, this is a cubed root. And then the 8, which is in the spot of the x, or the base, now becomes the radicand. So 8 to the 1/3 power is the same as the cubed root of 8. So notice how my denominator of 3 in the 1/3 becomes my index of 3 on the radical sign. And then the cubed root of 8 is 2. And I know the answer is 2 because if I take 2 and I raise it to the 3rd power, I get the answer of 8. So I'm confident that my answer is 2. Let's look at 64 to the 1/2 power. Now my denominator is 2. So that means on my radical sign, the index is 2. Now, normally we wouldn't write the 2 because if we leave the 2 out of it and we do not write a number in the index spot, it's assumed it's square root. But I'm going to put it in there just for this example so you can see the connection between the 1/2 exponent and the 2 in the spot of the index for the square root. So this means I'm taking the square root of 64. And again, I just wrote it without the 2 in the spot of the index. It still means the square root of 64. And the answer is 8 because 8 squared is 64. So I'm confident that my answer is 8. Okay, in those first two examples, notice how the numerator of our exponent was 1. We did 8 to the 1/3 power, 64 to the 1/2. Well, now we're going to take a look at what happens when our numerator is not the number 1. So let's look at our rule. The same rule goes for the denominator. So if I have x to the power of m over n, the denominator of n becomes the index of my radical sign. But now the numerator m becomes an exponent for the whole entire radical expression. So you'll notice I have the nth root of x raised to the power of m. Now, you'll notice there's two versions. You can put the exponent of m outside the parentheses, or you can put it underneath the radical sign with the base. The way that I circled it, I think, is the more friendly, I guess, version of the formula because it allows you to simplify without dealing with large numbers. It allows you to first take the root of the base and then raise it to the power instead of first raising the base to the power, which can cause much larger numbers. Either one of the formulas, though, is fine. Okay, let's look at this example, 16 to the 3/4 power. My denominator is 4, which tells me my index for my radical sign will be 4. So I'm going to have the 4th root. And then the 16 is the base. That 16 becomes the radicand. So now I have the 4th root of 16, but now the 3 in the numerator spot becomes the power for the whole radical sign. So I have the 4th root of 16 in parentheses, and then that answer will be raised to the 3rd power. So when I simplify this, first I'm going to simplify inside parentheses. The 4th root of 16 is 2, and then I'm going to raise 2 to the 3rd power, so my final answer is 8. So I worked inside the parentheses first, according to order of operations. I got the 4th root of 16 and then raised that to the 3rd power for 8. Now, you can also check this on your calculator. You can type the number 16 and then use the caret button on your calculator, which is the button that will raise a number to a power. But then when you raise it to the power, you want to raise it to the 3/4 power. Now, Depending on your model of calculator, you might need to wrap 3/4 in parentheses. It just depends if your calculator automatically puts the 3/4 in the spot of the exponent or if you have to put parentheses. But either way, when you press enter, you should get 8. All right, let's look at the next example. 27 to the 2/3 power. So the denominator of 3 becomes my index of 3. So I have the cubed root. And then my radicand is 27. And then all of that is going to be raised to the second power because my numerator was 2. So I'm going to do order of operations. I'm going to work inside the parentheses and evaluate the cubed root of 27, which is 3. And then when I do 3 squared, I get 9. And of course, you could check that on your calculator by typing 27 and raising it to the power of 2 over 3. Okay, here's a few more examples. Let's look at number 1. We have -8 to the 2/3 power. Now, we're also going to follow these 3 steps. So step 1 is identify the base. So in number 1, I first want to rewrite it. Notice how the negative sign is not in parentheses with the number 8. So this is the same as -1 times 8 to the 2/3 power. So actually, my base is just the number 8. My base is not -8. So you got to be careful of that. Okay. So now let's go through. My denominator of my exponent is 3. So that's going to become the index on my radical. So I'm going to have a cubed root. The base is 8. So my radicand is 8. So I have the cubed root of 8. And then my numerator is 2. So all of that will be raised to the second power. And then I multiply that final, well, not the final answer. I multiply the result of that by -1. So the -1 is the last number I will multiply by. So let's do our order of operations. In the parentheses, I want to simplify the cubed root of 8, which is 2. And then I'm going to square 2. So I'm going to have -1 times +4. And my final answer is -4. So be careful with that -1 on the outside. Okay, let's look at number 2. Now I have 81 raised to the -1/2 power. Now my base is 81, but because of the negative exponent, the first thing I want to do is take the reciprocal. So instead of 81 to the -1/2 power, this is 1 over 81 to the 1/2 power. So I take the reciprocal, so I no longer have a negative exponent in my expression. Now, in the denominator, I have 81 to the 1/2 power. Well, the denominator of my exponent is 2, which tells me I have the square root of 81. And since it's 1/2 power, meaning it's 1 over 2, I don't have to worry about an exponent because it's just raised to the first power. So I have 1 over the square root of 81, which is 1/9. All right, last example, number 3. I have -16 to the 1/2 power. Since the -16 is in parentheses, my base is -16. Which means I'm taking the square root because the denominator is 2, so the index is 2. That means I'm taking the square root of -16, and we know that the square root of -16 is not a real number. We don't have to say for I. We're just going to say not a real number because what's coming next is when we start graphing our exponential functions and our logarithmic functions, we need to consider restrictions on the domain. And if we see the square root of -16, we know that, we just know that we cannot include that ordered pair on our graph. So we're just going to say not a real number. And that's our answer. I hope you enjoyed this mini lesson on properties of rational exponents.